Hello and welcome back to another speedrun, IB Math Speedrun with me, Vince. So in this speedrun, we're going to be going through the chapter review of chapter 4, which should cover questions across all the things we've learned about derivatives and differentiation. So let's jump right in. So I'll be doing the even ones because, they're a bit harder. So first, find the following limits. Actually, wait. I'll do every other. Actually, no, I'll just do the even ones. Find the following limits if they exist. Um, and the first one, I'm not going to bother typing it out. First, we have the limit as x tends to 2 of negative x squared plus 5x minus 2. As x tends to 2, well, what does this factor out into? This is x. Oh, this actually doesn't factor. Hold on. Negative x plus 5x minus 2. As x tends to 2. I don't see a problem. Why would this not exist if it's at 2? So this would be negative 4 plus 10 minus 2. But wouldn't this just be 6? I don't see why this is not 6. Sorry, I mean 4. I don't see why it's not like 4, because just like any other equation, this will be equal to simply negative 2 squared plus 5 times 2 minus 2 is equal to 4. So I don't see a problem there. That one was pretty easy. Maybe a trick question. Okay, the next one is the limit as x tends to 0 of 8 minus 2x to the 1/3. Again, as x tends to 0, this simply tends to 2. I don't see a problem because it's just 8 to the 1/3, which is equal to 2. Yeah, I don't know. That's a bit weird. Okay, finally, the limit as x tends to infinity of the square root of x squared minus 2 over x. So this is like, and now we can see an interesting limit here. So square root of x minus 2. So we can rewrite this as x squared minus 2 over x squared, I believe. Yeah, square both top and bottom. Hold on, no, we can't. No. Ignore what I said. What will be the best way to go about this? We could multiply this. I guess we could multiply both top and bottom by the numerator. So we get x squared minus 2 over x times x squared minus 2 to the 1/2. So what do we get from this? We get x over x squared minus 2 to the -1/2. Sorry, to the 1/2 minus 2 over x times x squared minus 2 to the 1/2. Sorry about that. I'm back. So if we have, well, we already established that this is irrelevant. This will tend to 0. So we simply have to evaluate this limit over here. And as this tends to infinity, x squared minus 2 to the 1/2 will tend to x. Since we have, as 2 becomes increasingly less relevant, this will tend to 1/2. So therefore we have the limit of x over x. So this should tend to 1. So yeah, this limit tends to 1. So on to the next one. And okay, we now need to find whether values for which this function is continuous. So the function is 2x squared plus a, x is greater or equal to -1, and negative x cubed, for which x is less than -1. So for this function to be continuous, we need to make sure that at this point, -1, negative x cubed is equal to 2x squared plus a, when x equals -1. So in this case, this would be 1 is equal to 2 plus a, so a must equal -1. So yeah, okay. For the next problem, we have 6. Determine whether the series from n equals 0 to infinity, 2 times -1 to the n over 3 to the n converges, and if it does, find its sum. Okay, this is an interesting one. So we have n is equal to 0 to infinity, and we need to get the summation of effectively 2. Since both are being multiplied by n, this is 2 times -1/3 to the n. And, this should converge. And, well, why is that? I guess you can say, if you don't want to just plug it into the standard equation, we have as n approaches infinity, of the sum of these numbers, well, I mean, I guess you could just plug it into the infinite series already. So this would be equal to, yeah, you know what, I would just plug it into the infinite series. So we have u1 over 1 minus r, so we have we start when n equals 0, so we have 2 over 1 minus -1/3. In this case, it does converge because the common ratio is less than -1, is greater than -1. So we have 2 over 4/3, 1 minus -1/3. So we have, in effect, 3 over 2. So this should converge to 3 over 2. Yeah. Okay, so on to the next one. And so the next problem is asking to find all asymptotes in these equations. And the first equation is f of x is equal to 6x squared plus 7 over x squared minus 9. So we have to find all asymptotes. So we have to find both vertical, horizontal, and slant asymptotes. So for the horizontal asymptote, which is as x tends to this number, sorry, for the vertical asymptotes, which is as x tends to this number, y tends to infinity or negative infinity, we simply have the factors of x squared minus 9. So we have x is equal to plus or minus 3 as vertical asymptotes. Now, what about a horizontal asymptote? As x tends to infinity, what does this number tend to? So we have the limit as x tends to infinity of 6x squared plus 7 over x squared minus 9. Divide both top and bottom by x squared, so that we get the limit as x tends to infinity of 6 plus 7 over x squared over 1 minus 9 over x squared. So this simply tends to 6. So y is equal to 6 will also be an asymptote of this graph. So yeah, these two are the answers for that function. And then we have one more function we need to tackle, and that is x cubed plus x squared minus 4 over x squared. So we need to find all asymptotes of this graph. So for vertical asymptotes, of course, x is equals 0 is an asymptote. For horizontal asymptotes, let's check if there are any. So the limit as x tends to infinity of this And so if we divide all by x squared, we get x plus 1 minus 4 over x squared. So as this tends to infinity, this will tend to be insignificant, and so y will tend to x plus 1. So x plus 1 will also be an asymptote of this graph. So x equals 0, y equals x plus 1 will both be asymptotes of this graph. So this is a slant asymptote and a vertical asymptote. Yeah. Okay, on to the next one. So we have the question, given the function y is equal to x over x squared minus 1, find the vertical and horizontal asymptotes. Show the function is an odd function. Show that dy over dx is less than 0 for all x. And finally, sketch the function. Okay, so remember that an odd function is one that we can rotate 180 degrees and we should end up with the same graph. So first, let's find the vertical and horizontal asymptotes. So we have y is equal to x over x squared minus 1. The vertical asymptotes will simply be x is equal to plus or minus 1. And as for the horizontal asymptote, let's see as x tends to infinity. As x tends to infinity, x over x squared minus 1. So we have 1 over x over 1 minus 1 over x squared. So both of these, both of these will tend to 0. So this entire thing will tend to 0. So y equals 0 should be a vertical asymptote, a horizontal asymptote of this graph. Next, show the function is an odd function. And so this means if we rotate it 180 degrees around the origin, we should get the same results. And so it also means that for any value of x, so say if we put this in function notation, f of x should be equal to negative f of minus x. Or the negative function should be equal to the function when we substitute the negative number in. So let's test if this is true. So we have negative x over x squared minus 1 should be equal to negative x over negative x squared minus 1. And so this bottom part evaluates to x squared. And so these two functions are indeed equal because, of course, we can write this in the form negative x over x squared minus 1. So it is an odd function. Next, we need to show that dy over dx is less than 0 for all x. And to do that, we have to derive this function. So we have y is equal to x times x squared minus 1 to the negative 1 in effect. So we can use the product rule to get the derivative. That would be dy over dx is equal to x squared minus 1 to the negative 1 minus x times x squared to the minus 1 to the negative 2. So this would, in effect, be equal to minus x over here. We have normal function here. So let's all express it in terms of this. So this would be x squared minus x sorry. Oh, sorry, I forgot. In this case, this would be minus 2x, since we have to get the derivative inside the brackets. So this would be x squared minus 2x plus 1. No, minus 1 over x squared minus 1 squared. Ah, this should be 2x squared. My bad, I forgot about that. Hello, I'm back. So sorry, this should be minus 2x squared because it's actually minus 2x times the original x that was here. And so we get actually just minus x squared minus 2x squared. I'm sorry, minus x squared because it's x squared minus 2x minus 1. And so you can see for all values of x, this will be negative. If x is positive, x squared will be positive, so negative x squared will be negative. And when x is negative, the same. And when x is 0, this will still equal negative 1. So for all values of x, this function will have negative values. So if we were to sketch, the gradient will have negative values. So if we were to sketch this function with asymptotes at x equals plus or minus 1, y equals 0, it would probably look something like this. But let's check that using a graphical calculator. So x divided by x squared minus 1. Ooh, interesting. So I did not account, but actually there is a line that goes like this through the center, as you can see here in this graph. Yeah, so normally if you were asked to sketch it, I think you would be allowed to pull out a graphical calculator, but this is what the graph looks like. Very interesting graph. So anyways, on to the next question. And the next question says, given the function f of x is equal to x squared minus 3x plus 2 divided by x squared plus 3x plus 2, find the equations of all asymptotes, find the x and y intercepts, and C, find the x-coordinate of the extrema of the function. So let me just rewrite this because it's not clear here. This is x squared minus 3x plus 2 all over x squared plus 3x plus 2. So first, what are the asymptotes here? The asymptotes would be the factors of this equation, which is x plus 1 times x plus 2. So when x is equal to negative 1 or negative 2, these are asymptotes. And well, what's the y asymptote? Well, ignoring those x values, this equation should be equal to, actually, no, we can't simplify it. So we have the limit as x approaches infinity of x squared minus 3x plus 2 over x squared plus 3x plus 2. Dividing all by x squared, we get the limit effectively as x approaches infinity of 1 over 1. Since these terms would be cancelled out. So the limit should be 1. So as y approaches 1, this is also invalid. So those three should be the asymptotes of this graph. Yeah. So let's find the x and y intercepts. Okay. So the x-intercept is when y equals 0, and the y-intercept is when x equals 0, so we can substitute those in. So we have actually let's start with x equals 0, because that's a simpler one. So the y-intercept would be when both x equals 0, so this would be 2 over 2, so y equals 1 is the x-intercept. No, sorry, y equals 1. So the point 0, 1, yeah, no, sorry. the point 0, 1 is the y-intercept. So the y-intercept is at 0, 1. And the x-intercept is when y equals 0. So we have 0 is equal to x squared minus 3x plus 2 over x squared plus 3x plus 2. So it's clear this part doesn't matter because only the top part has to be 0. So we can factor that into x minus 2 times x minus 1. So we actually have two x-intercepts. And so the x-intercepts will be at when 1, 0, and 2, 0. Finally, find the x-coordinate of the extrema of the function. That's the maximum or minimum, I believe. So let's derive this. So we have, let's use the quotient rule this time. So we have dy over dx is equal to v times d over dx. So x squared plus 3x plus 2 times 2x minus 3 minus u times dv. So this is minus x squared minus 3x minus plus 3x minus 2 times 2x plus 3. No, it's, oh, it is actually minus 3x plus 2. So this is 2x plus 3 all over x squared plus 3x plus 2 squared. So this top part should be equivalent to, let's see, x squared plus 3x plus 2 minus x squared. Let us just factor this. 2x cubed, expand this. Minus 3x squared plus 6x squared minus 9x plus 4x minus 6 minus 2x cubed minus 3x squared minus plus 6x plus 9 plus 6x squared plus 9x minus 4x minus 6. So what cancels out here? That cancels out, that cancels out. This cancels out. Yeah? Is that all that cancels out? I think so. So we're left with minus 6x squared plus 12x squared. So this is plus 6x squared. So 6x squared minus 12 is what I believe we're left with. So we have 6x squared minus 12 over x squared plus 3x plus 2 squared. Now to get the extrema, we have to set when this is equal to 0, so we can completely disregard the denominator again. And so we have 0 is equal to x squared minus 2. So x must be equal to plus or minus the square root of 2. Is there more than one? Yeah, there's more than one. So x is equal to plus or minus the square root of 2 are the x-coordinates of the extrema of this graph. So yeah, on to the next one. So next question is f of x is equal to x minus b square root x when x is greater or equal to 0 and b is a positive real number. Find, in terms of b, the zeros of f, the intervals where f is increasing and decreasing the range of f and the concavity of f. Okay, so first we need to find the zeros of f. So 0 is equal to x minus b square root x. So what are the zeros? I guess b square root x is equal to x. So b squared x is equal to x squared. So we have b squared is equal to x, really. B is a positive real number. So the zeros of f would be when x equals b. Oh, sorry, no, sorry. It's x when x is equal to b squared. Oops. Yeah. So the intervals where f is increasing and decreasing, well, we need to get the derivative of this equation and look for where it's increasing and decreasing. So f prime x is equal to 1 minus, and then this is b square root x. So we need to get the derivative of b times x to the 1/2. And so this is simply 1/2 b to the negative x to the negative 1/2. Okay. Yeah. And so we need to find the values for where this is 0 and then use the sign test, or of course just get whether they're a minimum or a maximum. So we have 1/2 bx to the negative 1/2. So 1 is equal to 1/2 bx to the negative 1/2. So 2 is equal to b times x to the negative 1/2. So so 4x is equal to b squared. These will be the maximums and minimums of this function. And so if we get the second derivative, which is equal to 1/4 bx to the negative 3/2, and we substitute these values, this one value in to get whether it's a positive or a negative extrema. What do we get? So x is equal to b squared over 4. So we get 1/4 times b squared over 4 to the negative 3/2. Yuck. So this is equal to 1/4 b times 8 over b cubed. So this will be equal to 1/4 times 8. So this would be 2 over b. Since b is always a positive number, I believe b is a positive real number, this will evaluate to a minimum. So we get that this is a minimum point. So when x is less than b over 4, x is less than b squared over 4, this is decreasing, and when x is greater than b squared over 4, this value is increasing. Yeah, so that's correct. So next we need to find the range of f. Well, okay. We know the minimum is at b squared over 4, so let's see what value it outputs there. X, so this is b squared over 4 minus b times square root of b squared over 4, which is b over 2. And so this is equal to b squared over 4 minus b over 2, b squared over 2, so this is equal to negative b squared over 4. So this will be the minimum value that f will have, and the maximum is obviously infinite. So we will have the range is y, or f of x. I'll just put the range of f is equal to x is y is greater than negative b squared over 2 over 4, and that should be the range of this function, greater or equal technically. Finally, the concavity of f. This is concave up. Yeah, for all of x, it's concave up. We only have one turning point, and well, actually, let's prove that. Points of inflection are when f of x, f double prime of x equals 0. So we have 0 is equal to 1/4 times b x to the negative 3/2. So this will only occur when x is equal to 0. And the thing is, x is equal to 0 isn't a point of inflection since we don't have any values of x before 0. So there is no actual point of inflection, so this is concave up all the way. So yeah, that's that question done. Now on to the next question. 16, find the gradient. Oh, okay, so find the I'll just say it. So it's find the gradient of the tangent to the curve 4x squared plus y squared is equal to 4 at the point 2 over square root 5, 2 over square root 5. So we need to find the gradient of the tangent. Okay, so we just need to use implicit differentiation. So we get 8x plus 2y times dy over dx is equal to 0. So dy over dx is equal to negative 4x over y. Okay, so 2 square root 5, 2 square root 5. So this is equal to negative 4 times, 2 over square root 5 over 2 over square root 5. Since these two are equal, these two cancel out, so the gradient should basically be equal to negative 4. Is that correct? Yeah. Okay. So now on to the next question, and the next question is long. No, it's not long. The point A with coordinates A, B lies on the curve square root x plus square root y is equal to square root p, where p is greater than 0. The tangent to the curve at A intersects the axes at 0r and s0. Show that p is equal to r plus s. So, tangent to the curve at A intersects the axes at 0r, s0. Okay, so I guess we have to get the derivative of this. So we have root x plus root y is equal to root p. And tangent to the curve at A, which is at any point, really, so intersects the axes at 0r and s0, show that p equals r plus s. So first, let us find the tangent, the gradient of the tangent first. So we have 1/2 x to the negative 1, and then square root p is a constant. So plus 1/2 y to the negative 1/2 dy over dx is equal to 0, because remember p is a constant. So we have dy over dx is equal to negative 1/2 x to the negative 1/2. So we have, more or less, it's x to the 1/2. It's y to the 1/2 over x to the 1/2. So this is the gradient of the curve. And if it intersects the points with coordinates a, b, then we have b is equal to negative y to the 1/2 over x to the 1/2. A plus c. And we want to remember that we can express these coordinates, well, we can express these coordinates, at least one of them, in terms of the other. So we have square root a plus square root a plus root b is equal to root b. So root b is equal to root p over root a. So, root p minus root a. So we have b is equal to, okay, so we have more or less root p minus root a squared is equal to negative y to the 1/2 over x to the 1/2 a plus c. But then of course, at this point a, b, this would be a and b as well. And so we know that b to the 1/2 is equal to root p minus root a. So we have is equal to negative root p minus root a. So root a minus root p over a to the 1/2 times a plus c. So we have root p we have p minus 2 times root ap plus a is equal to, well, root a over, this is root a, is 1, so we have a minus root p over root a is, root p over root a times a is root a minus ap plus c. So our constant here is going to be, constant is equal to p minus the square root of ap. So we have our equation here. Y is equal to 1 minus root p over a x plus p minus root ap. So we know that it intersects the axes at 0, r. It doesn't matter actually that they intersect the axes, I believe. It just matters that we have two pairs of coordinates. This is 0. So r is equal to the constant p minus root ap, and s is equal to when y equals 0, so is equal to x at that point. So we have 0 is equal to 1 minus root p over a. Or actually, let's make a big root. S plus p minus root ap. So S is then equal to root AP minus P over 1 minus root P over root A. So let's just try adding them together, I guess. I'm not too sure where to go from here, honestly. So P plus root AP plus root, because there's so many places where we could have got wrong. Root AP minus P over 1 minus root P over root A should all be equal to P. So to prove this, cancel this out, make it simpler. So we need to prove that root AP is equal to P minus root AP over 1 minus root P over root A. And so we can multiply this to both sides. So root AP times 1 minus root P over A should be equal to P minus root AP. So we have root AP minus P. Ooh. Is it possible I made a mistake in the sign change somewhere? Hello, I'm back, and I finally figured out the problem. It's the problem that I put a minus sign here and a plus sign there. So this should be a minus sign, and so therefore all should cancel out. So we should get AP minus, not really this way, AP is equal to AP over here. So, yeah, minus signs. Anyways, let's move on to the next one. And so the next one is, let me just pull it up. A particle travels in a straight line, and its velocity at any time t is v of t is equal to 1 plus t minus square root 4t plus 9 meters per second. Find the particle's initial velocity the time when the particle comes to rest, the particle's acceleration at this time, and the intervals when the particle is slowing down and speeding up. Okay. So we need to find the particle's initial velocity, and we can do that when we just put time is equal to 0. So the velocity should be equal to 1 plus time minus the square root of 4t plus 9. So this should be equal to, well, when time is 0, the velocity will be equal to 1 minus the square root of 9, which is equal to negative 2 meters per second. So that's part 1 then. The time when the particle comes to rest. So that's when velocity is 0. So we have 0 is equal to 1 plus t minus the square root of 4t plus 9. So we have 4t plus 9 is equal to 1 plus t squared. So we have t squared minus 2t minus 8. Hold on, t squared minus 2t minus 8 is equal to 0. So we can factor this out into t minus 4 times t plus 2 is equal to 0. However, I don't think we're going into negative time for this, so the answer must be when t equals 4 seconds. So we need to find the particle's acceleration at this time, which we can get when we can get the acceleration function. So acceleration will be equal to 1 minus the square root of 4. Well, we need to get the derivative of this. So remember, we can express this as 4t plus 9 to the power of 1/2. So this would be 1 minus 2t times 1 minus 2, sorry. 1 minus 2 times 4t plus 9 to the negative 1/2. And so when t is equal to 4, we have the acceleration at this point is equal to 1 minus 2 times 16 plus 9, so 25 to the negative 1/2. So this is equal to 1 minus 2 over 22 over 5. So this is equal to 3 over 5 meters per second to the negative 2. And finally, we need to find the intervals where the particle is slowing down and speeding up. Okay. So we know that this reaches 0 once, and this is a positive function, so we should experience so past t equals 4, then velocity is positive, and before t equals 4, velocity is negative. Now the question is, how about acceleration? So we have acceleration is 1 minus 2 times 4t plus 9 to the negative 1/2. When does acceleration change? Well, we can set that when acceleration is 0. So in other words, 1 is equal to 2 times 4t plus 9 to the negative 1/2. So 1/2 is equal to 4t plus 9 to the negative 1/2. So 2 is equal to 4t plus 9 to the 1/2. So this will only occur when t is equal to, well, a negative value. So this means acceleration is likely positive throughout. Likely negative. No, likely positive throughout the duration. Yeah. So this means that the particle is speeding up the particle is slowing down when t is less than 4, and the particle is speeding up when t is greater than 4. So yeah, that is correct. Okay, next we have another word problem. The volume of a spherical balloon is increasing at a rate of 3 centimeters cubed per second. Find the rate at which the surface area of the balloon is increasing when its radius is 1 centimeter. Okay, so we have dv over dt is equal to 3, and then, of course, it's a spherical balloon, so we have dv over dr is equal to 4 pi r squared. So now to find the rate at which the surface area of the balloon. Okay. Okay. That's fine. We actually need to find an expression to express the surface area in terms of the volume. So the volume is equal to pi r 4/3 pi r squared, and surface area is equal to surface area is 4 pi r squared, I think. Let me just check that. Surface area of sphere, 4 pi r squared. So dv over ds looks like it is, well, v is equal to 1/3 times r s. Yeah. Or actually, I guess we can just do it like dv over ds is equal to dv over dr times dr over ds. So this is equal to 4 pi r squared times 8, so divided by 8 pi r. So it's equal to 1/2 r. Is that correct? Yeah, 1/2 r. So we have dv over dt, and we need dv. We have dv over ds is equal to 1/2 r. So ds over dt is equal to 2 over r times 3. So it's 2/3 r. Okay, I'm back. I'm going to reset this, and I'm going to do it a different way. So first, we're going to solve for dr over dt, or the rate of change of the radius. So we have dv over dt is equal to 3, dv over dr is equal to, what is this? This is 4 pi r. So dr over dt should be equal to 3 over 4 pi r. So, okay, that's dr over dt. Now we need to find ds over dt. And ds over dt, for pi r, so ds over dr is equal to 8 pi, I believe. 8 pi r. And so ds over dt, 4 pi r squared. So this should be 2 times 3 divided by r. I don't, honestly, I don't understand how I'm wrong. I think the book is wrong in this case. Like normally, yeah, maybe I'm wrong, but this time I don't think so. So we're gonna skip that question for now. I mean, we already got the answer. So now we move on to the exam style questions. So 24. So we need to consider this function defined for all real numbers, which is negative x squared minus 4 over x squared minus 5x plus 6 for x is greater than 2, a squared plus 3a plus 6 for when x equals 2, and e to the 2 minus x plus x plus 1 for x is less than 2. Oh, sorry, x is greater than 2. This is x is less than 2. So we need to first show that the limit as x tends to 2 of f of x exists. So from the left-hand side, we have the limit as x tends to 2 from the negative side, and this would be of negative x squared minus 4 over x squared minus 5x plus 6. So when x tends to 2, this tends to 0. Is that correct? Yeah, 0. This tends to 0. So if it's from the other side, so if x is tending to 2 from the positive side, so we have e to the 2 minus x plus 1. I'm not happy because it's not tending to the same value from both sides. Okay, from this side, as x approaches 2, x squared minus 4 approaches 0. Oh, but this might tend to 0 too. So that's a trick question. Okay, never mind. Let's go back on that. Okay, so we have x plus 2, and at the bottom, because we also have x minus 2, and then over here, this would be x squared minus 5x plus 6 is equal to x minus 2 times x minus 3. So in this case, we can cancel out the x minus 2's because we're doing a limit. So you have x plus 2 times over x minus 3. So if we divide both by x, we get 1 over 1. So the answer is 1. Is that what they're saying? X plus 2 over x minus 3. As x approaches 2. Oh, wait, no, sorry. No, we're not doing that method. Ignore that. So we have 4 over 2 minus 3 minus 1. Oh, negative of this entire thing. So negative 4 over negative 1. So we should be equal to 4 from the left-hand side. Next, as x tends to 2 from the positive side, we have e to the 2 minus x plus 1. So this should simply tend to 1 plus 2 plus 1, which also equals 4. So this limit does indeed exist. So as x tends to 2 does exist. So now we need to find this equation here, a squared plus 3a plus 6, for which this is equal to 4. So we know that a squared plus 3a plus 6 equals 4. So we know a squared plus 3a plus 2 is equal to 0. So a can be equal to 1 or 2. Negative 1 or negative 2. So yeah, those are the two possible values for which f of x is continuous. Okay, so on to the next question. And the next question is we need to find the derivative of g of x, which is equal to the square root of x over x squared plus 1, x being greater than or equal to 0. So we need to find the derivative of this equation. Let's use the quotient rule. So g prime will be equal to x squared plus 1 half x squared times x squared plus 1 times x to the negative 1 half minus 2x times the square root of x all over x squared plus 1 squared. Okay, and so we want to find a normal to the graph at x equals 1. That's what the question is asking. So we need to find a normal at x equals 1. So what's the gradient of the tangent here? This would be 1 half times 2 times, well, in effect 1 minus 2 times 1 times the square root of 1, which is 1, all over 1 squared plus 1, which is 2 squared, which is 4. So we have 1 minus 2, so negative 1 over 4. So the gradient of the tangent is negative 1/4. The gradient of the normal should be 4. So since the gradient is 4, we now know we have y is equal to 4x plus c, and then let's plug 4 into the equation. So we get the y value. So we get 2 over 16 plus 1, 17. 2 over 17. Oh, sorry, no, x equals 1. What am I doing? 1 over 1 squared plus 1. 1 half. So we get 1 half is equal to 4 times 1 plus c. So c must be equal to negative 7 halves. So y equals 4x minus 7 over 2 is what I'm getting as the equation. Let's just check if that is correct. So, yeah. So finally, explain why there is no tangent to the graph at x equals 0. Well, since the function is only defined for values for which x is greater than 0, there's simply no tangent because it's not defined. A derivative is not defined at the endpoint of a closed interval, so there's no tangent at that point. Okay, on to the next question. And the next question is asking us to consider some profits. So we have a table, and then year, profit. So the first column is 2000, then 2001, then 2002, then, oh, it's a long table. 2003, and 2004. So this is 98.5, 100.9, 101.1, this is in thousands of dollars, by the way, 101.2, and 102.3. So the first thing is we need to find the average rate at which the profits varied between 2000 and 2002. What average rate at which the profits vary? So like the average increase? Okay. So the average increase should be 101.1 minus 98.5 divided by 2. So like an increase at $1.3 thousand. And then the average rate at which it varied between 2002 and 2004. So 102.3 minus 101.1. 1.1 over 2, so it's 0.6. So between these two, it's 1.3, and between these two, it's 0.6. And then compare the values and state their meaning in the context of the question. Well, it simply just showed that the rate of the increase in profits is decreasing. In other words, the second derivative of the profits is decreasing. There's not that much to say. Yeah. There's not, yeah. I don't know why this question is here, honestly, but oh, okay, at least that was easy. Okay, next, on to the next question. So we have quite a long question. So a projectile is launched vertically from the ground. After t seconds, its height is given by h of t is equal to 112t minus 4.9t squared. So the initial velocity is 112 meters per second. So first, determine the height at t equals 4 and the height at t equals 5. Find an expression for the velocity of the projectile in terms of t. Find the instant in time t for which the height of the projectile reaches a maximum. Determine how long it takes for the projectile to hit the ground. And finally, sketch the graph of h is equal to ht, stating the domain and maximum. Okay. So, tall order, let's start. So, at height, at t equals 4, this is 112 times 4, minus 4.9 times 16. So this is 369.6 meters at h equals 4. At h equals 5, it's 112 times 5, minus 4.9 times 25. So this is 437.5 meters at the other height. Yep. So find an expression for the velocity in terms of t. If you know physics, then you should know that v is equal to u plus at. Since a is clearly 9.8, u is clearly 112. This is technically 112 minus 9.8, but you get the exact same result if you do the derivative, because derivative of 112t is 112. So dh over dt, which is equal to the velocity, is equal to 112 minus 4.9 times 2 minus 9.8t. So that's the expression. Find the instant in time t for which the height of the projectile reaches a maximum. That is when v equals 0. 0 is equal to 112 minus 9.8t. T is equal to 112 over 9.8, which is equal to around 11.4 seconds. Okay, determine how long it takes for the projectile to hit the ground. Again, physics cheat, it's just double the maximum time in this kind of Suvet model. But let's just solve it in anyways. So we have 0, anyways the height should be 0, so 112t minus 4.9t squared. So assuming the time isn't 0. So we have 112 minus 4.9t. So we have t is equal to double this, double 9.8. So 112 divided by 4.9 is equal to 22.8. 5, and as you can see, it's around double that. Okay, finally, sketch the graph of h equals 8t, stating the domain and the maximum. The graph should look like that. Let's be real. This is 0. This is time equals 0. This is time equals 22.8. This is the maximum height. And it's valid for within this domain. So it's only valid for which t. 0 is less than or equal to t is less than or equal to 22.8. And yeah, the maximum height is 112 times 11.4 minus 4.9 times 11.4 squared. So that's equal to around 639.9, or I mean, it's like almost 670. Yeah, so that's correct. Oh, there's more. Find the velocity of the projectile at the instant it hits the ground. The velocity at the instant it hits the ground is the exact same velocity as it lifted off. It's 112. But let's actually solve it. So at time 22.8, we have 112 times 22.8 minus 4.9 times 22.8 squared. And so this should be equal to negative 112. It's just that, because this equals effectively 2 times negative 112 times 22.8. That's what this is. And finally, show the acceleration is constant. Come on. This is the velocity function derived. Oh, not this. Show the acceleration constant, find its map. This is the velocity. If we derive it once more, we get acceleration is negative 9.8. And it's a constant, because if we differentiate negative 9.8t, we get negative 9.8. Acceleration, negative 9.8 meters per second squared. Acceleration of our planet. And finally, on to the last question. Okay, so this is quite a long one, and it states, a crude oil well W lies 75 kilometers offshore. An oil company is planning to construct a pipeline in 2 linear sections. The first section will run underground and take the oil from the well to a point A on the shore. The second section will run above ground and will take oil from point A to harbor H, where it is loaded. So the diagram kind of looks like this. So we have our offshore well W here, and then we have this first section, which goes to A, and then we have our second section, which goes to H. So we're given that the distance between the offshore well and the shore is 75 kilometers. Yeah, and does not say, well, anyways, it says that this distance here is 100 kilometers. And it's telling us to call this distance from the well to A x. So first we need to find an expression in terms of x for the total length of the pipeline. And that's pretty easy. So the first section here is going to be the square root of x squared plus 75 squared. And the second section is 100 minus x. So plus 100 minus x. This will be the total length of the pipeline. And then the next information is it costs the company 3 times as much to construct a pipeline below ground than it does to construct it above ground. So we need to determine the value of x that results in minimal construction costs. So more or less we have to multiply the value of this length by 3. So we have 3 times x squared plus 75 squared plus 100 minus x. And to get the minimum construction cost, we just derive this. So we get d d over dx, which is an expression for when you don't actually have a function, is equal to, this would be 3 times 1/2 times 2x. So 3x times x squared plus 75 squared to the negative 1/2 plus 100 minus x. So we need to find the value for which this is equal to 0. So 0 is equal to all of this. So we know that what can we say here? So 0 is equal to 3x over x squared plus 75 squared to the power 1/2 plus 100 minus x. So let's transfer this to this side. So we have x is equal to, actually, let's multiply everything by x squared plus 75 squared to the power of 1/2. So we get 3x is equal to 100, is equal to x minus 100 times x squared plus 75 squared to the power of 1/2. So we have, in effect, 3x over x plus minus 100 is equal to x squared plus 75 squared to the 1/2. So let's square both sides. So we have 9x squared over x squared minus 200 x plus 10,000 is equal to x squared plus 75 squared. So now we can multiply this back over to this side. So we have 9x squared is equal to x squared plus 75 squared times x squared minus 200x plus 10,000. Am I overcomplicating this? Probably. Is there a simpler way we could have done this? So 3s, yeah, times 100 minus x, 3 times the cost. I don't think there's a way to simplify that. So anyways, we need to find the minimum of this function. So it's x to the 4 minus 200x cubed plus 10,000 plus 75 squared. So 10,000 plus 75 squared is equal to 15,625 x squared minus 9. So that minus 9 is equal to 15,616 x squared minus 75 squared times 200 minus 125,000 x to 3, 4, 5 plus, oh boy, 75 squared times 10,000 plus a large number. Is there no simpler way to do this? I'm going to look for a simpler way. I'm fairly sure that there is a simpler way that we can express this. Or not. I mean, honestly, okay, let's just try. Minus 56250,000. Because we're already here anyway, we might as well just try. So you got the derivative. Let's set this to 0. Oh, oopsies. Sorry, I've made a little mistake. And it's that this term 100 here does not exist. Because if we get the derivative of this, we actually eliminate this 100, and this simply becomes minus 1. So we get 0 is equal to all of that minus 1. So we get, let's just erase that completely. So we get 3x times x squared plus 75 squared to the power of minus 1/2 is equal to 1. So what can we do here? 3x times is equal to x squared plus 75 squared to the power of 1/2. So 9x squared is equal to x squared plus 75 squared. So 8x squared is equal to 75 squared. So x squared is equal to 75 squared over 8 squared. So x is equal to 75 over 4 square root 2. Sorry, that's not 8 squared. That's just 8. So 75 over, actually, hold on. 75 over 4 times 2. This should only be 75 over 2 square root 2. So I think the book's made an error here. I'm just looking at it right now. They say it should be equal to 75 over 4 square root 2, but it should only be equal to 75 over 2 square root 2. So hence show the total length of the pipeline as 75. Find the total length of the pipeline. Okay, so this is simply 75 squared over, well, we know x squared equals 75 squared over 8 plus 75 squared plus 100 minus 75 over 2 square root 2. So this is going to be equal to 3 times 75 over 2 root 2 minus 75 root 2 over 2 plus 100. So this should be equal to 75 times root 2 plus 100. The book says 75 over 2 root 2, but I disagree. I just think it's wrong. So yeah, that's all for the speedrun. I hope you enjoyed it, and I hope to see you in the next chapter. So see you then.